3D printing news Unpeeled. Today we're talking about 3D printing ceramics for the U.S. military, the U.S. Army even, and what's else? Oh yeah, a 3D printed data center and a new Chinese metal 3D printer. So the first one is SINTX. I'm not sure how to pronounce this actually. It's SINTX Technologies. Has a subsidiary. It's a technology transfer subsidiary, and they have signed a CRADA, Cooperative Research and Development Agreement, with U.S. Army Command Capabilities Development Command, Army Research Laboratory, DEVCOM ARL. DEVCOM ARL is a really key part of the U.S. military in implementing new technologies, specifically for the Army. They've been doing a lot of work with 3D printing lately, not as much as the Air Force Research Lab maybe, but still quite a bit. Usually, well, very, very forward-looking stuff. And in this sense, they're going to probably do it with ceramic 3D printing and ceramic matrix composites. SINTX is been functioning as a 3D printing service for these ceramic composites. They make ceramic filled kind of resin and other type materials. And they develop parts of pyrolysis. We've talked about pyrolysis a couple of times on Unpeeled here, and it's really a process where you can use a polymer or use a resin type component, so make a really accurate type component. And then using pyrolysis, you can make something that's extremely heat resistant. And we've seen a couple of labs do that, and I'm really fascinated by that technology as well, and so is the U.S. Army. Now, why are they doing that? Well, ceramics makes components that are usually really difficult and really expensive to machine, maybe even impossible to machine, and are very high temperature, very high wear resistant, very long lasting components. And that's the reason why everybody turns to ceramics. I say turns to ceramics is there's a lot of like metallurgists, there's a lot of mechanical engineers, and all these people are used to dealing with metals. There's a lot of chemists and other people and designers trained on polymers. There's just not a lot of people trained on ceramics and using ceramics. There's not a lot of technical ceramics companies out there. The industry is relatively small. So it's really a material of last resort. And it's not really well understood. It's typically expensive. But with 3D printing, what happens is you can build up that material quite inexpensively. And if you use like a ceramic laden resin or a doped resin, you can actually use just a regular resin printer to make a ceramic object that you later burn out. And these pyrolysis materials allow you to use SLA or other vat polymerization processes to end up getting a pyrolysis type model. And that brings us to a newer way and more interesting, perhaps even way cheaper way of making ceramics. We can make hypersonic vehicle components, engine components for turbo machinery. We can make antenna components. There's a lot of things that the U.S. Army specifically would want to do with this on lengthening the life of certain components like gun barrels and stuff like that. But another good piece of news, or interesting tidbit of news, is that what SINTX has done already is make ceramic armor for like Humvees and other kind of vehicles, and also body panels and composite armor for soldiers. Now, in that sense, 3D printing that kind of thing could be very interesting, and you could make multi-level reactive armor, armor that's much more complicated, armor that is really quickly made and adapted to combat certain threats. Think of a new missile that overcomes your reactive armor. To replace that, would take a really long time. But if you had really standard issue plates, you could just redesign this and redesign it with a better design to counter that new missile, for example. That could be a very, very exciting kind of thing for them. And that's the type of stuff we're looking at. And, just making ceramic components that last longer is going to really make a big difference for them as well. So just a lightweight structure for something, or a lightweight kind of structure for antenna or an engine component that lasts longer, that could be a really valuable technology for them in the future as well. Anything that lasts longer is good. That means I could take a tank on the road longer, or a gun barrel will last longer. And that, of course, in the field is very expensive. A U.S. soldier in a very far off battlefield may cost the country about $1 million per soldier per day, depending on the situation. And you've got maybe 6 to 8 people resupplying that person. And the 6 to 8 people resupplying that person also have to be protected. They cost less than he does at the front line, let's say. But there's also a significant cost. And so that Army matches on their stomach thing really comes to expression ultimately in 3D printing, where we can say, wait a minute, we can replace that component. But with ceramics, we can not only replace it, but we may be able to make it last longer. So that's an interesting development. And again, the United States military is becoming our largest paymaster at the moment. We are seeing private investment slip away, public investment slip away. And at the moment, the people pumping money into this technology is the U.S. military through the aforementioned DEVCOM, Army or Air Force Research Lab, DARPA, other bodies. and also just the mainline units and things like that. We're seeing a huge investment. Like we're predicting multi-billion-dollar investment in the technology, which has, of course, its risks, has a lot of ethical concerns as well. But in terms of funding the industry is our next horizon. So that is one thing. The next bit of news, these are some of the ceramic components that SINTX makes already. They also make things for implantation in the body, carbide type materials, stuff like that. The next piece of news we reported on a couple of months ago, actually in March of last year, when we were talking about 3D printing a data center. Now, the Kraus Group has completed the Wavehouse Campbell Heidelberg building and has given it over to Heidelberg IT Management. It's a 100-rack server building, a data center building in Baden-Württemberg, in Heidelberg. Heidelberg is the home of several notable companies, one a big printing company, 2D printing company, or 2D printing like a printing company from way, way back when, and the other one a big cement company. So that's no coincidence, of course, and you will guess what cement they're using. So this is Baden-Württemberg, a very prosperous and doing very well industrially type of part of Germany. And it's a 600 square meter building. And that 600 square meter building is made by a Cobod BOD2 printer with help of Perry 3D, who's getting involved everywhere, also shareholder in Cobod as well. And it uses 450 tons of material from Heidelberg and had 140-hour print time. Now, before you think, oh, wow, that's a couple of days, notice that this building started construction, right? Or the initial construction was I think the 31st of March last year, and they've just completed it a couple of days ago. So maybe the print time's 140 hours, but all the other stuff around it, including certification and checks and all this kind of stuff, takes significantly longer. Now, of course, we're talking about the holidays and stuff like that. Everyone went for vacation, but still, I like the fact that this is just one of these things where, like, yeah, the print time was really low, but actually, it took quite a bit to get this thing done. Now, the reason I think this is really a thing that's noteworthy to bring to you is because, well, I don't really believe that much in-house 3D printing, or, I believe in it, but everyone else is saying it's the biggest thing ever. And I'm much more excited by buildings like this. Imagine a data center building that you could make with a walls with a really specifically designed air gap, for example, to better insulate heat, or a really specific shape to better draw heat to a particular area. And you drew it to a kind of a heat sink type of structure, or a Stirling engine to turn that heat energy into electricity so you can then power the data center, make it more efficient. Or imagine you channel that heat away to heat a public swimming pool or something like this, or to heat another building. That is the kind of stuff we could be doing with 3D printed construction. And for me, in a data center where we've got this thing that needs to be is really purely utilitarian building, all right, they're optimizing the structure in a way we can't do with normal bricks and construction, making this a really exciting thermal management structure is, to me, really, that's frontier breaking. Because if we can go to these data center people and say, hey, look, your data center, we're going to save 3% energy if you build it with us, and our construction costs are going to be about the same, they're going to do the math, and they're going to conclude that 3D printing construction for them is a better way to go. And then we can make them cool as well if they wanted to. But the cool thing is that energy costs are such a huge component of what they do. Is if we can, for example, design the building in such a way that it works with a Stirling engine to recoup some of that heat, and it's super thermally efficient and insulating itself and channeling that heat towards electricity. Well, then you've got maybe the optimal structure for a data center, and that is that's a value proposition. Then it's not, oh, ooh, cool, it's a 3D printed building, or we're saving money on it somehow. No, it's like, no, this is going to save you a significant amount of money across a lifetime of this building. That is the only purpose of this building, is to construct to be a data center. And then we're not doing what a lot of construction industry does, like, how many square meters do you need? We'll build the walls like this, or we'll make it look pretty on the outside, right? No, we're saying, no, we're going to functionally engineer that building to manage the heat. And, think about, if you could do the advanced modeling, you could go into there and say, these are the type of racks we're going to use. This is the heat is going to come from this area, and we could model it and change the building to where you're going to place the racks, for example, right? And all that kind of stuff, and then change it to absorb heat where the heat will be output for these servers. So I think that, to me, is something that excites me much more than just simple buildings, where we're saying, no, we can engineer this building to be the best data center building in the world and save you more money than you could if you were doing another construction method. And that's what I love about this. The next thing is E+. So E+ used to make clones, essentially clones. Like, it was, like carbon copies of existing metal 3D printers made by other people. including down to the menu structure and the look of it and everything like that. Now, they are kicking things into high gear now, making systems that are more original, let's put it that way. And this is a very, very important printer. Now, of course, everybody's talking about the Chinese companies releasing these really big machines, right, for aerospace parts. And that's an important part of the business, but they have very relatively few customers. This is where the future of metal printing is going to be fought out, though. For new space, it's going to be these huge machines, multi-million-dollar 12 laser machines. But in this quad laser market, this is the market that is going to be the Toyota Camry Ford 150 of the metal 3D printer market. This is a quad laser printer. It's optional 1, 2, 3, or 4 laser, which I think is really, really brilliant and nice. What they need to do, and they haven't really explained that they can do this. Other people have this as an option, but no one's really been able to really explain this very well to customers. And that's the idea. Look, start with 1 laser. You don't know anything, buy the box with 1 laser. Later on, you upgrade to 4 when you start doing production. And then you don't need to change your settings. Now, that kind of stuff that for example, Renaissance is working on to a reasonable degree, and other things like that, that is stuff that people want. And then you can make the same box, which is still a lot of steel. This thing is 5,000 kilos, right? 5-ton machine. It's still a lot of steel, right? So you don't want to lose too much money on that 1 laser one. But if you have that 1 laser box in everyone's shop, right to do their qualification, to their initial testing, and then they can just upgrade the number of lasers as they go along, and it works seamlessly. That works seamlessly is the key part here, right? As opposed to it's technically possible now, and you don't have to requalify all your parts. That would be absolutely beautiful. And then you would have a really winning system, because that's a really big cost element for a lot of people. Now, that's a bit far away, but I love the architecture. I love the idea that you can choose 500, 700, and 1 kilowatt lasers as well. I wonder how complex the system is going to be for them to implement, but this to me is, where I would place, if I was them, I'd place all my effort in this system, because this is the one that could see really, really big adoption. It's a 400 by 400, 450 millimeter build volume. It's got a bidirectional recoder, which should save them time. Not sure how they work with that on the patent side of things, but it should save them a significant amount of time. I've previously said a couple of times, I used to jokingly call metal 3D printers or powder bed fusion systems like recoding machines, because they spend like 1/3 to 2/3 of their time recoding. So as opposed to printing, right? So any kind of improvements to the recoder, or any kind of speed up on that recoding thing and faster laydown is of course going to really do a lot of good for you. There's top-down powder loading, which should really help in an industrial type system, an industrial type environment where you could just have a gantry type of a thing do that kind of work for you and save you a lot of space, a lot of time. And there's, they have got a sieving solution, a feeding solution, powder management, that kind of thing. And to me, if they make this a configurable architecture, when they say, yes, we'll ship these guys a lot of steel for a 1 laser 500 watt product, but if there's an upgrade path to bigger lasers and quad laser, I think this is the be all end all in terms of the market. This is the Ford F-150. As in, this is the important car where if Ford screws up the F-150, they're in trouble, right? And of course, all the other models are to round out the lineup. If they do a good F-150, they can then make a ton of profit on the Lightning and all these really high-end models, and that really makes their entire company, their entire year, or their entire quarter. And it's a similar thing. The quad laser is going to be commoditized thanks to what the guys are doing on the light engines and better light engines coming out on from these companies. And this is inevitable. And this is a system which still makes a ton of sense for somebody who's just doing bulk standard production, right? Bulk standard production of a lot of stuff. This is going to be a system you want to look at because maybe it's affordable, maybe it's effective, and then you could get a quad laser Renaissance system. You can get an AOS or an SLM system of comparable size. And then for these kind of industrial bulk spend, you're making brackets all day, you're making teeth all day, that kind of stuff. Okay, then all of a sudden, maybe the Chinese stand a chance. Maybe some people will say, you know what, we'll go for them, right? Once they've established themselves. So this is the key element, the system that really will be the future of this company and a lot of other ones, in my opinion. Anyway, so I hope you found this somewhat useful. My name is Joris Spiels, and this is another episode of 3D Printing News Unpeeled. Have a great day.